So this next example is non-normal data. It's from a study which one of the vets in the vet school, Mike Thrusfield, carried out many years ago, and he's put it in his textbook on veterinary epidemiology. And in this study, I think it was a cluster sample survey that took place in a region in Africa, and they wanted to measure what the prevalence of a particular disease was. They couldn't possibly look at all the farms. Apparently there were 865 farms, or indeed all the animals within the farms. So they took a sample at random. 14 farms were sampled at random, and some of the animals were sampled at random to be looked at as to whether they'd got the disease or not. And these are the actual numbers that have the disease at each of the farms. So this is binary data. They either have the disease or they don't have the disease. So you could sort of think about a logistic regression model, but we'll think about a mixed model. So if you want to estimate prevalence, a very naive estimate would be just to sort of add up all the diseased animals, 476, and divide it by the total number of animals, and we'd get 0.157. So that's what our simple estimate and the 95% confidence interval would be. But what we could also do is consider fitting a very simple mixed model with the farm effect as random. And if this is done just by chance, we get exactly the same overall estimate of prevalence of the disease, but we now get a wider confidence interval because the model found that there was more variation in the amount of disease between the farms than you would expect by chance. If there was only the amount of variation between all these farms was only what was expected by chance, this variance component would have been 0. So we've got a bit more than expected by chance, and that's reflected in this confidence interval, which is now a bit wider than it was before. So if we'd just gone with this naive estimate, we'd think, well, the amount of disease in all the animals across Africa is somewhere between 14.4% and 17%, whereas when we fit the more appropriate mixed model, we find that that confidence interval could be as much as 23.6%. So it may well be that that's how much disease there is in this area. So it's quite a different range of possible for the amount of disease. So in that case, it was quite important to allow for that in the analysis.